Guys, welcome to the shop. Now this week I got several different things I want to share with you. Got a little project. I want to do a few test cuts on the K&T mill, and of course I got some other stuff. I'm wearing a t-shirt. It's Kentucky weather, man. No ice and relatively warm, so I got my this old Tony shirt on. I got another one, I'll show you. Well, while I was at it, I picked up a classic A-Bomb 79 t-shirt also. Still several more creative shirts that I want to get and stuff. I really like, trying to support those guys. Now, I don't know what the deal was, but when this shirt showed up at my house, it had metal chips in the pocket. I thought that was strange. But this old Tony shirt had cat hair all over it. I thought that was weird. But anyway, I need to get some shirts soon. I want to get some made up. I'm still not set on a design yet. But mine will probably show up at your house with a bottle of nasal spray in the pocket. I'm just messing. This is all a joke. These are great quality shirts. They're brand new. But today I want to do some test cuts with the K&T. I've got a large block of stainless in the vise. I've loaded up the 6-inch base, or it's a 5-inch base mill. Loaded it up, so I'm ready to give it a shot. This big piece of stainless is scrap, so we can sacrifice it to the metal gods and turn it into small pieces. So let's get started. All right. So the reason why I would like to get some shirts of my own is because I'd really like to go to the bash this year. And, for a couple people fly across the country and stuff, that gets pretty pricey, so I'd like to maybe do something like that to help offset some of the cost, because I really would like to go. So man, that's a pretty nice looking face mill. I'm going to be running this thing, I think, around 165 RPM. Let's get it warmed up a bit. I think that looks about right. It is a large chunk, but it's got a lot of holes in it, so it's scrap. So I'm going to be running dry too. No lube on this guy. Carbide, if you can't flood it, really you should either run coolant or no coolant at all. I will use some cutting oil, but no coolant. We're going to kind of take it easy, but I'm going to, let this thing eat a bit. Definitely, like I said, this thing's not got 100% matching inserts in it, but it ain't gonna make any difference. So that's 0. Pretty sure this is 316 stainless. that's 136 RPM and 1.25 inches a minute, 250,000 depths of cut, 5 inches wide. And it's handling it no problem. Those inserts may not like it too much. The stainless is pretty nasty, really. Slowed it down a bit. It's 136 RPMs, 1 inch a minute, 1/4 inch deep, and I got a fan because you couldn't see nothing. But it's doing that pretty easy. It's getting hot though. Really, this is a flood coolant job, and it would do this no problem, I think. The depth of cut's not a problem. This is handling that, you know, no problem. It's a pretty aggressive cut, especially in stainless. Well, that was definitely on the hot side, for sure. You know, got some discoloration on the edge of our nitrided inserts. Actually broke one of the non-coated ones. But you know, they were battered. They were in the space mill when I got it, and they were battered to begin with, so you know, whatever. That's a test, so it doesn't really matter. It didn't hurt anything. It wasn't already hurt. Check that out. And that is something. And that's a respectable finish for that kind of cut. Let me bring you over here and show you. I had to stop a couple times, of course, because I'm filming. Alright, so not too bad really. You can see I stopped about 3 times. First time to slow it down because it was definitely too fast. But then a couple times to move the camera or stop and get a fan to blow that away. But I mean, you can feel that one. That's where I stopped though. Not bad. So it's a beautiful day today, and I'm taking a break on my lunch hour to shoot a little film here, show you a couple things, maybe give a few guys some updates. I've had several people ask about our large compressor in here. I'll show you in just a second, because I had showed in a couple previous videos that our large gas compressor was having an issue. It's just a large sample compressor, so all it does is take a stream of gas from our process and compress it and send it to our sample analyzing unit, or conditioning unit, which is there. So it's a large 2-stage compressor, which means I guess one cylinder is for volume and one is for pressure. This is a diaphragm pump, which means that the incoming sample is separated from the actual compressor and stuff. the guys who paint cars and stuff will understand. You know, you don't want oil and stuff in your air supply when you're painting a car because it messes up the paint. Well, that applies to a sample that, you know, a gas sample that you're going to analyze. You don't want contaminants from the compressor getting into your gas stream. So it has a diaphragm, a big thin metal membrane that actually separates the incoming gas from the compressor itself. So it works off oil pressure. So this thing had issue building oil pressure, and come to find out it was a sheared key in the oil pump, which is behind this cover. I didn't get any video of changing that simply because, you know, they don't pay me to video, they pay me to work. And you know, it's simple repair. We just changed out the, hold on, we got a guy coming in on a Bobcat. We just changed out the oil pump altogether because of the damage done to the oil pump due to the sheared key. So now guys, I know I'd been having some audio issues on my channel, and I'm well aware of it and working on it. This oil going down in my sump, so I've got the pig mats stuck in the drains. I can't wait to get the flood coolant running on this thing. Then you can, you know, really take advantage of this machine's capabilities. wised up. Next time I'm gonna put some covers over these T-slots, man. That caused a lot of extra work. Hey,
What are you doing?
I'm cleaning my mess up.
You got some food ready in there?
Alright, good. I'm gonna start. What we got?
Barbecue.
Love it.
Love you.
Love barbecue. Alright, here's a little project that I'm working on. It's really just a piece of scrap out of my scrap pile, and I've turned it into a lap. Well, I'm starting to turn it into a lap. You can see it's just an anodized block of aluminum that I bored an inch hole in, and it's got a slit in it, and I'm going to use a couple set screws so I can adjust this thing open, or a couple thumb screws so I can tighten it down and close the bore up some. Now I still need to score this bore in here. Probably should have done that while it was on the forejaw at the house. Score the bore in here, that way it holds some of the lapping compound, and deburr this edge, that way it doesn't wipe the compound off as I slide this, you know, back and forth across the bar that I want to lap. This is actually the mandrel or arbor that I'm going to be using to hold my inch bore cutters on my cutter grinder. So I'll show you a little bit of it and some of the lapping. Alright, so I've got the lap and a vise here, and all I'm doing is scoring the inside with some lines. I probably should have, like I said, done this on the lathe, but they don't have to be, you know, perfect. They just need to be pockets for the abrasive material to sit in, so it doesn't, you know, or so it has a place to stay. Cleaned it up a little bit on the belt sander. I mean, it's ugly as it gets, but it'll work. Got my serrations on the inside. I put a 5/16 18 set screw in the center here. This will act as a spreader if I need to open my bore up a little bit. And then I'm going to put, I've got one in, but I'm going to put another thumb screw over here, and these will act as a closer, so I can close the bore up a little bit. I'm using to tap it, just doing it all by hand. You know, nothing has to be crazy accurate on this thing. A little Starrett 174, and I've been looking for one of these for myself for quite some time. This is actually a friend of mine at works, but yeah, they're a handy little tap wrench, especially when you're running in, you know, this is a 632, so, you know, and we're tapping in aluminum, so, you know, doing it by hand. So we're gonna, this is some 600 grit silicone carbide lapping compound. Spread some of that on there. Got the lathe bed protected. And definitely got a tight spot right there. Just work it back and forth. You know, as the lap wears, I'll tighten my thumb screws. Alright, so just put a shine on it with lightly with a piece of gray Scotch-Brite. And for my purposes, that'll work pretty good. It's not perfect. I wasn't trying to get it perfect, but I couldn't have it oversized. Well, for just messing around, I think that went pretty well. The non-coated, I had 3 non-coated inserts in this thing, did not hold up very well. There was a lot of heat we were generating, and really a flood coolant job. But next time I run this thing, I'll have all matching inserts in it because my friend Carlos Adkins sent me the inserts that I was missing. So thank you, Carlos. He's been with me for quite some time. So I'll replace those 3 that were non-coated, and then we'll try it on a large block of mild steel that I have out there. I really want to see how it does, dialed in really well, and see what kind of finish I can get, and what kind of cut I can take with this on mild steel. So thank you, Carlos. I definitely appreciate that. That was very nice of you. Now the shaft that I lapped for cutting my for grinding my 1-inch cutters, man, that thing turned out really nice. And if you want to get something to size and consistent, a lap is definitely the way to go. And there's nothing hard about making something like that. Just a scrap block of aluminum with a slot cut in it for adjustment, and some grooves in the bore to hold the abrasive material. Run it back and forth, check it a lot, and man, that if I run a mic across this, I get almost no variation over the entire length, simply because of the lap. I was getting some variation in it, but I mean, it's amazing. So got me some collars so I can lock this down, slide the table back and forth, and sharpen this big shell mill. I wanted to try this, but it's I don't have very many of these, and the ones that I do have, they're all just dull enough to where I don't want to run them, because you can't judge a finish off of a dull cutter. But now I can sharpen this guy up and actually give it a fair run and see how it does. I've got that same big block that we were cutting out there, the stainless. I've got it on the shaper now. Now I can't remember that I've ever cut stainless with the shaper on my channel, and I've only cut it a few times with that shaper anyway. So let's go over there, let's run it, and see what kind of finish we can get on the shaper. Block doesn't look too big in this shaper vise. This is going to be quick. I'm not going to take a real big cut. I just want to see what kind of finish I get. Let's do 15 thousandths. Well, let's do 20. See how that acts. Do 20 thousandths per 20 thousandths depth, 10 thousandths per stroke, just light. I say it's going to give us a good finish. same tool that I would run on mild steel. No coolant really necessary running this slow, you know, with a shaper. And it's hard to beat a shaper finish. It's just a really sharp, decently sized radius, quite a bit of positive rake. Nice. Look at that finish. In my opinion, the only thing that beats a shaper or a planer on really large flat surfaces is a big grinder. Check that out. No coolant, no lubricant. You know, this could get better. That's nice. That slight waviness, I think that's actually in the metal itself. You can't feel it. Oops. There's the tool I just used. Just a large radius and rake. So I've got a quick little indexing job here. I just got to cut 4 flats on the end of this shaft. And I'm using a little Kalamazoo. It's just a 5C collet indexer. It also has 24 divisions like a lot of them do. But this one you can't lock in a number of divisions like you can on the one that I showed last week. This one you have to actually, either count your steps or, like I've done, mark them with a Sharpie so I can just index or cut, index, cut, and so on until I get all the way around my part. It has a lock, spindle lock here, which is pretty neat. Not quite as versatile as the one I showed. This one's simply horizontal, but I guess you could mount it on index plate or angle plate. This one does have the benefit of being quite a bit smaller, and you may be able to fashion a small chuck or something on it. I'm not for sure, but for small shafting 5C work, this is really nice and real rigid for its size. So let's cut these flats and then I'll show you what this is for. this stuff is. It's tough to get a finish on. Alright, so we're just going to put a radius. This is a 1/4 inch radius. We're going to put it at the transition here. That's it. I think that looks a lot better than just a sharp corner. Alright guys, now there is the part that I just pulled off, or I just showed you me pulling that off the milling machine. I cut that, you know, the hex, or the, not a hex, the square drive on the end. And all it is a simple chuck key. It actually turned out really nice. I did not have a chuck key for my medium-sized 4-jaw at home, so I decided to make one. I still got to make one more. I like to have two, one full-size chuck key and then one small one, so I can get on both sides of the chuck and move apart without it falling out into the chip pan. Now, what I did here, that is just a piece that I believe that's 1095 on the main body, and the handle is 4140L, so it's 5/8, and then the body is 1 inch, transfers down to 3/4 of an inch with a 1/4 inch radius. So proportionally it looks pretty good, and it really feels good. I don't like anything smaller than a 5/8 handle. They just kind of hurt your hands, in my opinion. So I went with the 5/8. So drilled the body and reamed it 4 5/8. Drilled and tapped 5/16 18 set screw in the back, and put a divot right in the center of the handle. That way the set screw sets in the divot of this handle. I can take that set screw out, slide this out, and it hasn't marred this handle, so I can take it in, take it out, put it in without worrying about the set screw damaging the handle. Just something I wanted to do. A lot better than something like that. I hate little rinky-dink chuck keys. And I get asked, probably once a week, what do I do for a living? And I'm not going to tell you where I work, but I work at a large energy research facility in the state of Kentucky. This is one of the buildings that I work in, one of many. And what I do is install, build, design, this kind of stuff, just anything you can imagine, really. We work with a little bit of everything, considering what we do. And take samples from our process. This is just one experiment of many that we got going on. Modify some things that we need, we can't buy, or if we can buy a product, it needs modified one way or another. So, I do all that. And, get to brainstorm and hang out with a bunch of really talented guys. So my job is excellent, really. Like everybody, we wish we made more money, but as far as job itself, I really love my job. It's awesome. And as you can imagine, if you like this kind of stuff, an interesting and neat environment. So that's it, guys. Just a little chuck key and a fairly simple video this week. I haven't had a lot of time, really. It's been busy. So thanks for watching, guys. I definitely appreciate it. If you need anything, you can contact me through my email. Thanks to the guys who made a donation on my PayPal button on my homepage. I truly appreciate it. It helps keep the lights and stuff on at the house, and keeps us moving. So thanks, guys, and thanks for watching. Thanks to my patrons, and I'll see you next time.